Hello and welcome to another episode of TWiML Talk, the podcast where I interview interesting people doing interesting things in machine learning and artificial intelligence. I'm your host, Sam Charrington. In this, the final show of our Deep Learning Indaba Series, we speak with Vukosi Marivate, Chair of Data Science at the University of Pretoria and co-organizer of the Indaba. My conversation with Vukosi fell into two distinct parts. The first part focused on his PhD research in the area of reinforcement learning, and we discussed several advanced RL scenarios, including inverse RL, multiple agent RL, and using reinforcement learning when you have an incomplete knowledge of the environment. We then moved on to discuss his current research, which broadly falls under the banner of data science with social impact. Specifically, we review several of the applications he and his students are currently exploring in areas such as public safety and energy. As we close out this series, I'd like to send a final word of thanks to our friends at Google AI. If you've got an interest in machine learning research and want to level up your skills in one of the top ML research groups in the world, you should take a moment to learn more about the Google AI Residency Program, which recently opened up applications for prospective 2019 residents. The Google AI Residency is a one-year machine learning research training program with the goal of helping individuals from all over the world and with a diverse set of educational and professional backgrounds become successful machine learning researchers. Find out more about the program at g.co/AI residency. And now, on to the show. Hey everyone, I am on the line with Vukosi Marivate. Vukosi is the chair of data science at the University of Pretoria and was a co-organizer of the Deep Learning Indaba. Vukosi, welcome to This Week in Machine Learning and AI.
Thanks for having me.
Absolutely. Why don't we get started by having you tell us a little bit about your background and how you got interested and involved in data science and machine learning?
Yeah, I guess I have a background in electrical engineering. That was my undergrad and master's. When I was doing my undergrad in electrical engineering, I got to a point where I said, I don't think I'm interested in this power stuff, but I am interested in artificial intelligence and data. So I moved to a stream here at the University of the Witwatersrand in Johannesburg, which allowed us to work on more data problems and more coding. And by the time I was doing my fourth year at the university, or being a senior, I was working then on AI, specifically doing some work with neural networks at the time. And then I stayed on for another year at Wits University, did a master's looking at some reinforcement learning work. I was very interested in machines can learn to make decisions, and you only have to give them this kind of reward. And so after spending that year doing that, I had applied also for a scholarship, a Fulbright scholarship, to go to the US. And one of the schools I had chosen was Rutgers University because of who would then become my future PhD advisor. I was this is one of the people I read about when I was reading about RL. So it could be interesting to work under him. I then, in between that, started working for the CSIR in early 2009. And a few months later, I was then off to New Jersey to start at Rutgers on the PhD program. And I then had Michael Littman as my PhD advisor. So another thing, again, as you're going through the motions of doing a PhD, you look at the area with some depth. I work on some work in inverse reinforcement learning. I worked a bit on trying to think about having multiple reinforcement learning learners all at once. But the thing that kept on making me wake up every morning was I'm really interested in making reinforcement learning a little bit more practical. So how do you do things like evaluation where you don't have access to a simulator or a complete environment? So if you think about things like medicine, if you might think about things like education, these type of areas, you're not really going to experiment on people with your reinforcement learning algorithm. So you want to do your evaluation offline. And to do that, you need to take care of a couple of things. So evaluation here, meaning that you want to see how well your model after it's learned actually does without having to deploy it. So you can't say, hey, you're going to learn how to treat cancer. And then after that, you build a model and you say, okay, now the model is going to be applied on real patients. That is going to be problematic in some ways. There is work in that area to make that actually much more possible. But that's the thing I was interested in. But I kept on being interested in this again. Hey, I really enjoy working from like a challenge that's out there and then working backwards into what then models will be useful, what learning algorithms will then be useful to then develop. And at that time, that was at 2011, 2012, I started hearing this thing of there's this term called data scientist. And it's people who will wrangle with data, use kind of a different techniques, not necessarily just from computing, might be from statistics, it might be from social science, and then try to kind of tackle these problems. And that's where then I kept on gravitating towards that. So by the end of my PhD, I was like, okay, let me go try and see, as I'm going back to South Africa, to see if I can work in data science. And that's where, arriving the last 3 years or so, mostly I was based at the CSR, working with a team of other data scientists for about 3 years. And then now I've moved to University of Pretoria, then as the chair of data science, still continuing some research with colleagues or prior colleagues at the CSR.
Did the transition to data science or that your kind of blossoming interest in data science lead to a change in direction for your PhD research, or did you complete that in reinforcement learning?
I completed the PhD in reinforcement learning, but the work basically became this kind of looking at education. We were looking at health applications and health challenges, and then working to build up tools for evaluation in that area.
You mentioned a few things in the RL area that I haven't heard much about. The first of those is inverse RL. What's that?
So inverse reinforcement learning is, in the general reinforcement learning framework, it's you've got an environment, you've got an agent, which is the machine learner that you're going to have. That agent can do actions. So it's allowed to choose some action and then it gets carried through and it might move around. So think about the, dumb example. You have a Roomba in a room and it can choose to move, to move around, and then it can choose sometimes to vacuum. What you do is you say, okay, I'm not going to specify what you must do, but I'll give you a reward for something, right? So I'll give you a 1 if you vacuum the dirt or something like that, and I'll give you a very negative reward if your battery runs out, right? So the Roomba then, just given those signals, will go around and it will explore at the beginning. It will try different actions. It might go in and just vacuum in a place that there's nothing, so you won't get a reward. But then sometimes it will vacuum on somewhere where there is dirt, and its sensor would have said there's dirt, but it didn't know how to interpret it before. And after a while, it will learn, look around for dirt. If there's dirt, vacuum it off. And then if the battery dies, I got a very negative thing, so keep track of the battery level and things like that. So over time, you think that you will inculcate in it, it will learn all these expected kind of behaviors. So in inverse reinforcement learning is that there is no reward that's specified, right? So you don't have a reward, which actually is hard to specify sometimes. But what you do is that you can actually observe somebody do something. Right. So you actually go in and maybe you see other Roombas. Or you have a human actually have a remote control to the Roomba, and it moves around and it does things. And then from there, what the goal of the learning algorithm is to do is to actually learn what the reward function would have been to actually replicate the behavior that it's seen.
I guess what this makes me think of is imitation learning. Is that a name collision, or are these related?
Yeah, they are related. So that's one of the kind of other ways, like imitation learning, there might be multiple ways to do it, but inverse reinforcement learning could be one of the ways that you do imitation learning.
Okay.
Yeah. But one of the things that is interesting, if you do really capture the reward in a good way with a good representation is that you can then transfer it between domains. It's hard, it's still not trivial, but you can then learn like what's important to who you've been observing, and then you move it to different domains and then try to then estimate what behavior you would have seen from that person or thing.
Can you give an example of that?
So let's say you've got the Roomba again. It goes in like, into a room. You show at the beginning, you train the Roomba you move around the Roomba. You learn, okay, there's things such as dirt, there's things such as battery state, there's things such as obstacles. But now you just adjust the room, or you move the Roomba into a new room. Because it's learned the reward, it doesn't need to imitate anymore. It could just take the reward that it learned before and then say, oh, I'm in a new room, but I kind of get the rules.
Mm-hmm. Got it.
Yeah. So that's a good, you kind of can then transfer that reward to something else.
I love the Roomba example. I've never heard anyone use that. Usually we're talking about video games and robots, and like, I guess the Roomba is a robot, but usually we're talking about video games, but the Roomba is a great example for RL. Not that the actual Roomba actually uses RL, but...
Yeah, I like making examples that are kind of very much more closer to people's like regular lives, even though like most of us, I don't even have a Roomba,
right?
but it's like once you say it, people get it. Like, oh,
yeah.
Okay, yeah, I see it now.
Yeah. Are Roombas even still a thing? Do they still make those?
There are a lot of them, and I've been trying to figure out how to get one from Xiaomi. It's not a Roomba; it's some other brand. I mean, other name. Yeah, hopefully we don't have to hit that. Yeah, but they still are there, and they're getting crazy.
So you also mentioned multiple RL learners. Kind of obvious from the context what that refers to, but I haven't seen much in terms of published research in that area. What are kind of some of the major challenges and results that folks have been seeing with multiple learners?
Oh, this has been a while working in that space, but you can think about different settings. So one is that you could have like learners that have to cooperate. So working together to solve a bigger, like high level goal. So like, you can have a team playing a game. Here we can talk about football, which now has changed. I'm back in South Africa, so football means something else. So yeah, it'd be soccer. So you could have multiple, they're trying to play soccer, and then again, you give them rewards, but then now they have to learn how to cooperate. That's one way of thinking about it. That's not really what I was trying to do sometime in my PhD. But one way was, okay, you have these different learners, but they only get different experiences, right? So their time that they spend in the environment, it only gets them to see different parts of the world. Now, how do you take this and then almost try to fuse their brains to get to something that is much better? So it brings you back to like ensemble methods, and could ensemble methods actually be something that works in reinforcement learning?
Okay, interesting. Yeah, so now that you mention it, the first of those examples, I did an interview recently about the OpenAI Dota OpenAI 5, which is like these 5 different agents that are operating in this environment and need to figure out how to cooperate. And they do some interesting, some interesting kind of emergent behaviors we're seeing there. But okay, so you mentioned inverse RL, multiple RL learners, and then evaluation in incomplete environments, which you kind of alluded to with the multiple learners, where they're kind of learning different things independently, and then you're fusing what they're learning together. Was there other work that you did around these incomplete environments?
It's not really incomplete environments, as opposed to you don't have access to them. So one of the things was like we wanted to look at health, chronic disease management, and like things like you can do things like marketing, because you've got lots of data. So you don't have access to the environment in chronic disease. So you don't have access to a patient, but you can have historical diagnostic information and also follow-up diagnostics. So in this case, I was looking at HIV, which funnily enough, I'd also worked in my undergrad briefly, looking at missing data for HIV, but then now I was actually looking at treatment. So I'm going to simplify it again. So you've got multiple patients going through treatments for HIV, and what you want to do to learn from there is a policy that in the future, when you get a new patient, you can take some information from them and be able to personalize a treatment. But that treatment for HIV is sequential. So it's not simply a one decision is made and that's it. So you're not going to choose a drug cocktail and it's going to last for the life of the patient, right? So you're going to have multiple times you have to make decisions. So meaning you give drug cocktail number one, it works for a while and then it might stop working, unfortunately, given how HIV actually progresses. And then you have to then make a choice of switching to another treatment. And this could go on for a couple of times. So we restricted the problem into, I think, only 2 stages, where you say you're going to get your initial treatment, and if you switch, what should then be the next treatment? So this becomes a sequential decision-making problem, which again is very nice for reinforcement learning because that's exactly what you want to learn. But what you want to do is that because you're not going to have access to the real patient to do the evaluation after you've learned from the data, we split the kind of learning into a process where some learning is used to just learn a model of the environment given the data that you've seen. So it's almost like you're building some sort of simulator, but it's going to have noise because sometimes you haven't seen a specific drug cocktail used enough for you to really be sure what kind of effect it's going to have on a patient. So you have to then bring in uncertainty of saying that, okay, here you might end up with a viral load between here and here. So we then built up a model-based reinforcement learning algorithm that estimated then the effect that drugs would have on a potential patient. And the information that we captured from the patient was like their demographics, some information about the disease at the beginning. And then from there, you then run an reinforcement learning algorithm that estimates then, if you were to give a drug cocktail that was drug cocktail number 1 was this and drug cocktail number 2 was this is likely how well you'll manage the disease over the next X amount of turns.
Huh. That's interesting. So it's like part of the environment is modeled probabilistically, and the agent has to figure out what to do with that constraint.
Yes. So again, it brings up this thing of you now want to allow people to do RL without necessarily having access to the real kind of thing, but they've got enough prior data to do something at least useful. And then you then could then say, okay, I want to also then evaluate how close I am to the real world in some way. Some of the work of Susan Murphy at University of Michigan, they've done a lot of work kind of in this area. And she was on my PhD committee.
And so kind of fast forwarding, you're now focused on data science at University of Pretoria, and a lot of your interests are centered around this idea of data science with social impact. What does that mean for you?
So for me, social impact means we have a world that has kind of challenges. And from these challenges, you can come up with very interesting data science kind of problems that you can then do research on. And some of these will kind of have a flavor that's very similar around the world. So for example, while I was at CSR, one of the initial areas we had looked at is trying to think about public safety, and then thinking if we have the constraint that we might not really have access to raw public safety data, could we use a proxy? And the proxy we had come up with was maybe social media is there. People might be describing incidents that are going on. It might be a fire, it might be a car accident. And from there, can you build something that at least gives you an indication of what might be going on in a town or in a city? So that is one. The other could be, hey, I want to, there's data that I have access to, and we want to look at behavior in that data, and we want to pick out things that don't make any sense. So you want to look at anomalies. So work with students to work on anomaly detection algorithms with that in mind, and hoping to get to a point where now, let's say you're looking at behavior of people purchasing electricity, which is one project we had worked on at the CSR, and I still continue to collaborate with some people at CSR on this. But you want to look at how people purchase electricity, and if they have behavior that is anomalous, try to then go and understand why they are anomalous. And sticking to the energy thing, you can then think about the same thing of saying, hey, now I'm not going to look at electricity purchase, but I might look at generation. So South Africa has been trying to build on more renewable energy, and you have a couple of researchers who are interested in, hey, where should we be putting wind farms in the country? So we got a couple, a lot of data with wind data for all of South Africa with about 5 by 5 kilometer pixels. And I work with some students then to say where are the most suitable places for wind farms, given some constraints, like there's places where you can't build, you can't be too close to communities, you can't be too close to national parks, you can't be too far away from roads, you can't be too far away from distribution lines, those type of things. And with that, it kept on continuing, where it's like, okay, fine, now you kind of know where your wind farms are going to be. Now you want to predict how much wind you're going to have, let's say, over the next couple of days, and then or a couple of hours, because then you can then predict demand. So that's been going on with a couple of collaborators working in energy kind of a prediction. Yeah.
So there's a bunch of interesting stuff to dive into there. Maybe to get started, I've got some questions about this wind farm placement problem. And in particular, folks have approached this placement problem with different types of optimizations that, aren't necessarily machine learning. What does machine learning add to the mix in this particular type of problem? And how do you what kinds of data science methods do you end up applying?
Sure. So with the placement one, we work with a student at the African Institute for Mathematical Sciences, and there we use a suitability method. So yes, it wasn't machine learning. It was just a kind of a statistical mathematical model that said, given what you rank what's important to you, and given the rankings, then it changes the suitability.
Got it.
Right. So yeah. So their student Shanae Frankran, she worked on a stability model, and that model we were able then to tweak it. You could then say, okay, I'm not really interested in the environmental things, for example. If you are that way inclined, then you could remove it, and then from there it'll say, okay, these are the best places to build. You might say, yeah, the cost of how far I should be from roads, don't really care about it, and then it will change the suitability. But where machine learning comes in now is on the flip side of saying, okay, fine. The one other thing that comes into perspective is that you might have an area, you have some historical data in terms of how much wind was being generated, and now you're interested in how much wind will be generated over the next 24 hours. So you've built your wind farm, and you just need to make a decision on, am I going to have to fire up my coal power station or my nuclear power station? I don't think nuclear power stations probably just go on and off, but let's say my coal power station, but I need to know kind of what's going to happen tomorrow. So they've been continuing collaborations with Boubacar at Ames, with a couple of other students, to then say, hey, can we build predictive models that can then just predict 12 hours ahead? And we've also brought in Nicoline Buerta, who's also at CSR, who had worked on a couple of models before, but now we're using deep learning for that.
In this whole wind farm area, both the placement and the prediction of output, it strikes me that there are a lot of moving parts to a problem like this. Can you kind of, walk us through where some of the major challenges were and how they were addressed?
Yeah, so getting all of the data, I think, was challenging. So the partly lucky thing is I have a wife who works in renewable energy.
Okay.
So, which could have also spearheaded that I keep track of this research area, as something that's just keeps on kind of ongoing.
So data science step one is
yes. So in this case, I do remember some times where I would ask a student will ask and say, oh yeah, I need access to data that letters like this. I don't know where to get it. And then I would just ask my wife, and she'd be like, oh yeah, this would be on the Department of Environmental Affairs website, and you would be able to get it. So things like protected areas, things like the national grid, so where all the big transmission lines are, those type of things. So you have to do kind of a big exercise on capturing from the designer, from a potential client, what they take as being informative, and then from there saying, okay, what data do you have? And from the data they don't have, go and find it outside to say, okay, we have to go find this data.
And so were these various things that you were tracking the protected areas and the grid, were these provided in a useful way? Like, did you have to go from, I don't know, some kind of description to like bounding boxes or lat long or something for various features?
Yeah, so you're going to have assumptions that you're going to have to make, especially now you're working on like a 5 by 5 kilometer cell. So you could say how many wind turbines can fit, or will you fit in there? Are you going to make an assumption that you're going to put only like, in 1% of the area? The simplest one is just to say I'm going to put one wind turbine. It's not really true because what happens is that if you put wind turbines next to each other, they're going to have wakes, and from the wakes they actually then impact on how much energy is actually going to be generated in total. So it's not simple, but you can make that assumption and say, I'm just going to have one wind turbine, and now I'm going to just try to figure out how much power will be generated. You have different heights of that a wind turbine could be. You have different configurations of those wind turbines. So we had to kind of allow some flexibility with that, of saying a user of the system can choose and say, I'm interested at at a turbine that's at this height using this type of configuration. Here's how big its wingspan is going to be. If you're trying to look at where all the major roads are, I'm trying to remember if we kind of did a hack on the Google Maps API. It might have been of trying to figure out if there was a major road going through every block, and then from there estimating how far you are from a major highway. Yeah, so I think it was something of I think we had written some script for Google Maps to identify where all the highways were and how far each 5 by 5 kilometer pixel was from the major highway.
And so for these various features, did you end up encoding them binarily? This one has a grid, doesn't have a grid, has a highway, doesn't have a highway, and then just kind of counted pixels? Or did you, were you kind of treating it more fine-grained than that?
For Shanae's work, there was a little bit more fine-grained decisions that were made, and just like, are you near, are you somewhere not too far, and then are you far? And so you can have those knobs, and then you can also kind of play with them. You can also then quantify them as cost instead, and then say how costly is this going to be. And with some things, a protected area, it's either it's there or it's not really. So if there's a national park there, you don't build. Mm-hmm. Really, so it's a very negative. If I was thinking about rewards again, it would be just a very big negative reward.
Right.
yeah, kind of things like don't do it. And then if you had then perfect where you had good wind, because that was the other thing, is that do you have a lot of wind that's in that area, and then also what's your slope? So is it very sharp slope? If it is, you don't want to build there. You want to build as close to flat as possible.
And you mentioned that some of these various data sets were on government websites. Was this project something that could have been done by anyone? Were all the data sets publicly available, or was there some private data that was used to figure this out?
Yeah, so the wind data specifically, not that there is wind data that you can get for South Africa that's open, but the one that we were using was one that was part of a study inside the CSR, so they did give access to the students to work on it.
Okay.
On there. So you wouldn't necessarily have access to that, but I can point out people to kind of, I think there's a couple of stations across South Africa that are used and have public data where if you want to go download the wind, I think it's called Wind Atlas South Africa.
Okay.
You can get data, but it'll be for specific areas that are covered at the moment, but not every cell. The one that we had there was a model that was used to extrapolate for the whole country what the wind map would have been.
Yeah, you also mentioned you did something on the utility side. Is that was different than the wind farm project, right?
Yeah. So again, with the social impact, what I've been trying to do is get to a point where we're working with some of the local municipalities here in South Africa to look at some of their problems. So there we had worked on, you've got electricity data in terms of purchases on a monthly basis. And from there, you can do kind of things. You can do analytics where you're just looking at, okay, what's kind of the spend patterns. One, which I still want to work on, is now looking at these deviations from those spending patterns to try to identify behavior. So one that the city was interested in, City of Tshwane, where I live, and I work is, could somebody have installed solar, for example, and how would we then capture that in the system? And the students we were working with on that also had kind of tried to figure out a couple of heuristics to do this. So one was bringing in weather data again and looking at days or months that were particularly humid or they had lots of cloud cover. During those months, you would expect that the solar use would be less because there'll be less power actually generated. And then you want to then see if that meant that the household during that time would then spend more on buying electricity from the city.
What were the data sources that were used there?
So that one, the data is internal to the city in terms of the electricity purchase data. And then external is like using weather information and then using mapping, which you have access to mapping for the country. So that it's not as involved as the wind prediction one.
Okay, and what kind of models did you end up producing for that?
We're still trying to work on some anomaly detection models for it, so that's not complete as yet. But we are working on writing up on the analytics part of the work, and then there's one on trying to look at the segmentation of the customers. So you're actually using a recency frequency monetary value analysis, so it's called RFM, and it's used a lot in marketing. But then using it now to understand the different baskets of customers that the city has.
I'm sorry, what was the RFM?
Recency, frequency, and monetary value.
Recency, frequency, monetary value. Okay, and can you give us an overview of that model?
Sure. Yeah, that's more. You calculate for each customer, like in the last 6 months, how much they bought, when's the last time they bought, and how many times have they bought, for example. And from there, you're then going to find some baskets. So you can find that, there's baskets of people who buy a lot, buy very frequently, and they bought within the last month. And some people might be that they buy very infrequently, buy small amounts, and there's a little.
Okay, and so you're using those metrics, the recency, frequency, and value, as a way to kind of cluster or segment the customer base?
Yeah, it's a clustering mechanism, basically. And you can test it against your things like your K-means as well.
The goal in applying that technique is what?
So there is then you can think about, what if then I wanted to estimate if some of my customers are in one batch and I was to find a way to move them to another batch, what could be the impact on my revenue, right? Because each group will have specific characteristics, and there might be that you're trying to identify and say, okay, maybe then you have people who would likely be moving to solar or something like that. So if I then said the people who are frequent users started using solar and they moved to another batch, how much money would I lose from them moving to solar? But maybe how much could I gain if I offered a product that was much more compatible to households that use solar? So one might be I buy electricity from them at different, at different times of the day, and then I sell it to them back at night. But I can take that same electricity I bought from them and I sell it to other people also and make more revenue. So it's kind of gaining those insights.
You also mentioned the public safety project that was based on some social media analysis.
Yeah, so this has been like a thread now that's run through probably the last few years, is just working on natural language in one way or another. So initially, when I started 2015 or so, it was just to go like, okay, could we use social media as a way to identify if there's public safety issues? So you just want it's a very coarse and not accurate way. So one could be, if people are complaining about an accident and they describe that there's an accident in a specific area in the city, could we pinpoint that? And then from there, kind of come up with a map that is just showing you from people going on Twitter or public Facebook pages, and putting this up. So that's where we kind of started, and we worked on a kind of an initial model that was very basic language processing model. And then we worked on it to then say, okay, one of the challenges that you have is that you can't really label a lot of the data. So you can only label like some subset of it. So then we worked on then doing kind of something like very rudimentary semi-supervised learning, where you take a model, you take your data that you've labeled, you train a model, and then you try to train more of the stuff that you haven't seen, and you want to see if it will actually impact your performance. We took into account maybe even network effects. So identifying kind of stuff about who's posting, because there's these questions that come up about, can you trust all the information that you get on social media? Maybe there's things like, if you have somebody who has no followers and it just recently showed up, maybe it's not, you should just filter that out and not try to classify that. And then started working with a couple of students, on things around, again, using short text data for a couple of things. So one has been a PhD student who's working on identifying authors. So it's again connected to this kind of trust thing. So saying who actually wrote this, short piece of text, and can we identify that? So he's been working on a kind of a deep learning frameworks to be able to do that. There's been more work in now extending some of what we had done on using short text as a way to understand. So right now, still working on some methods to bring in more robustness in learning from short text without a lot of data. So what might happen, or what I'm hypothesizing, is that if you're using social media as a data source, some of the things that might happen over time is that there's a quick change in language sometimes. And because of this, and also because you have got not that many words, people might say the same thing in multiple ways, but you don't have, again, you're not a Google, you're not a Facebook, so you're not going to have almost infinite amount of resources to actually label everything that you have, but you might have a subset that's labeled. And how can you use that smaller subset of data and try to make it kind of bigger, and then by that improve how your machine learning model is actually going to perform over time? So you don't want it that you train something and then 3 years later it actually is really bad.
You mentioned in there this kind of sub-project of identifying the author of short pieces of text. Can you elaborate on that? Meaning identifying the author of a tweet, for example, or identifying the author, meaning so you have the tweet but not the account that posted it, or are you trying to correlate it with authors that are outside of social media, or what exactly are you trying to do there?
Yeah, so there, I'll use a more topical example today. Is just that you might have, yes, a short piece of text, and what you're trying, you say, sure, it says it's from this person, they're saying it's from me, but then you can actually look at the content and say, oh, actually, this is not from this person. This type of content is actually generated by these other people, right? So typically, yes, this might move into, hey, how does fake news get generated? There's likely some generator that's not that clever, we hope. So that's one way you can think about it. Another way you can think about it is you can see people taking content without attribution on there, and you can kind of build up a source of kind of way of linguistic style that has happened. That is in that text. So Abidium Mudube, who's co-supervising his PhD, he's working on that, and it's been kind of a way to understand, oh, this is actually real new content. It's not something that somebody else posted before, and this person might be just reposting in a way. You can think about it in terms of bots, of identifying bots. You can think about it in terms of terrorism, in terms of trying to identify where source of information might have come from.
Are you comparing it to other things that user has tweeted to see if it's anomalous relative to what they've tweeted? Are you comparing it to the entire corpus to see if there's some large group of users that are all kind of tweeting the same things or the same way? Are you comparing it to some offline, totally offline corpus to see if you can correlate authors in one corpus to tweets? It seems like you can do a ton of different things with this.
There's a lot of different ways. So yes, one which you've highlighted, we're not doing it. In this case, is you could just look at the behavior of a person and okay, they write about this, they tweet about this, they might be a blog, they blog about this, and then something shows up and you're like, okay, something's off here, and that flags saying something is odd, but then that doesn't really give you kind of power to then say, okay, where could this have come from? But that's maybe you can then put that as a second item and say, we're going to deal with this. But a way that is like maybe the simplest way to think about it is that you could say, okay, I'm going to characterize for something major where content comes from, right? So if you're looking at bloggers, so you could, if you're a medium, build up a huge database of all your bloggers and what they create, and then you build a machine learning model that then every time you get a piece of content, you can say, oh, it comes from this author, right? With high probability, I can tell you that this is the author who likely wrote that thing. But then yes, there you're scaling with lots of labels, right? Because now you have a multi-class problem, and you could have hundreds of thousands of labels that then if you're Twitter, you know, millions, if not billions, over time that you've kind of gotten into. So the classes might be different given different constraints. So one, you might just say, is this original, or if is it not? Like and that could be a simple dichotomy that you then use as a labeler, and then you want to now build the architecture, like a deep learning architecture that can learn well from that, because you don't have a long string of text. You then can do even other things. You can then say, okay, fine, I'm not going to look at one tweet in isolation. Maybe I look at the last 5 tweets, right, and then see what's actually going on.
What kinds of models are you looking at with that one on the deep learning
Uh,
side?
Yeah, it's kind of character-based text models, and yeah, using RNNs and CNNs.
Maybe to kind of wrap things up, I'm wondering, as you look across this portfolio of projects focused on social impact applications of data science, are there common threads or trends or challenges that you tend to see when you're trying to apply this set of tools to these types of problems, or do they vary widely and don't have any commonalities?
Yeah, there's some things you learn through time. So one is kind of how to define projects in a good way is good. So you have to have a common language with who you're working with. So people come to you and say, we have this problem, we think machine learning can assist. Like, and then you go like, okay, what kind of data do you have? And why do you think kind of predictions might help or anomaly detection might help? And taking the time to kind of get a common language is useful, because then I think makes it much more interesting. One is to stay away from taking the hammer that you have and everything looking like a nail, that analogy. Yeah, so sometimes you just go in and go like, okay, yeah, maybe this is not for me. I think you can solve this very simply. We don't need to do it in this way. So let's get somebody to help you with the simpler way to kind of do that. With other things like I've given with natural language processing, it's been interesting because you have a problem. One, I hope to really get going is looking at things like conversational systems for like people who are working together in organizations. I'd seen this from looking at some kind of workers who work in government, and they chat a lot, and you might not have a way to track what's actually going on in there. But now you're thinking, oh, machine learning could be useful in there because you can identify the context of what anybody's saying at any time, and from there be able to guide in resolving a problem that they're trying to work together to solve in a way. So that brings in kind of a lot of layers of things. So I enjoy that. I guess that problem kind of solving, maybe it's part of my engineering background of saying, okay, fine, this problem that's out there, how you break it down, and how do you then take out the chunks that you'll do some science on, and then some other parts are practical. Who do I find as a collaborator then who will take care of the practical parts, and then I'll go look at some of the machine learning with a couple of the students I work with or the other collaborators that I work with, and we work on that. The other one is, maybe that also drives me, is seeing people are trying things out there. I'm organizing a workshop at International Data Week, which is on from the 4th to the 8th of November, and we have a session there on data for good. And again, going to see people, and I know you're going to see people like in education, trying to use data science in education settings, and seeing the problems that they're kind of having. And all the time, it's like, that thing of like quantifying some behavior and then trying to use that to either predict or diagnose. And because you're seeing all these people, it means that there's also then decision makers behind them. So these decision makers are trying to go like, okay, we know we've kind of gotten this data, that we've either been collecting ourselves, like given like example, the municipality using electricity data, but we really need to use it to improve the services that we provide for citizens. And it's rewarding in that way, that if you come up with something and it's like, it really gives some insight that people didn't know before, that it could actually then make impact, right there in your community.
Oh, that's great. Well, Vukosi, thanks so much for taking the time to chat with us. I enjoyed learning about the various projects that you're working on.
Yep. Thank you for having me. And I guess we look forward to, again, having people next year at next year's Indaba. There's obviously a couple of workshops that are coming up in different spaces or conferences that I might be at, or some of my other collaborators are on. So I'm on Twitter, so you can find me.
Are you at NIPS this year?
I will be speaking at Black in AI.
Okay.
Yeah, so I will be in Canada. So it's just, making sure I can get there. But I will be there. Like one of the things now, again, being back in the South, the global South, is I haven't had to experience the winters for a while. And so it's like, oh, damn, you're going to be in Canada in December.
Yeah.
Yeah, so I spent some time in New Jersey. So the winters were nice and warm. Nice, the snow is beautiful, but at the same time they really were depressing. So being back in South Africa, it has been very nice, because here they're like, oh, it's winter, and you're like, no, it's not.
Nice. Well, I'm looking forward to meeting you in Canada then.
Okay, thank you.
Awesome. Take care. All right, everyone, that's our show for today. For more information on Vukosi or any of the topics covered in this show, visit twimlai.com/talk/193. Thanks again to Google for their sponsorship of this series. Be sure to check out the 2019 AI Residency program at g.co/AI Residency. As always, thanks so much for listening, and catch you next time.